Welcome, Curious Minds. Today, we're diving into a stack of compelling sources you've shared with us, really focusing on the ever-evolving world of cybersecurity. Our mission, like always, is to pull out those key nuggets of knowledge, help you get informed without all the noise. We're looking at how some, old vulnerabilities are popping up again in new places, and also a really critical exploit that went from 0 to 60 discovery to active exploitation almost overnight. Okay, let's unpack this. First up, imagine an old enemy showing up with brand new weapons. NVIDIA put out a security notice recently. Pretty high severity issue affecting a lot of their DRAM GPUs. What makes this really interesting, though, is that researchers at the University of Toronto just published a paper showing how something called a rowhammer attack is being used on these GPUs. Can you maybe walk us through what this rowhammer thing is and why is it suddenly back?
Sure. Yeah, rowhammer attacks are definitely not new. They first popped up, I think, around 2014, primarily hitting CPUs back then. And, people thought they were mostly dealt with, mitigated. Basically, a rowhammer attack works by rapidly accessing, they call it hammering, specific physical rows of memory chips. You do that over and over, and it can cause electrical interference in the rows next door, enough interference, and bits can flip.
Flip bits, so like change data.
Exactly. Corrupt data, or maybe even change how a program runs. It's a physical hardware attack, fundamentally.
Okay, so the big news from the Toronto team is that these attacks, which we kind of thought were CPU problems, now work on GPUs. What does that really mean? Why now? And what made it hard before?
That's the core question, right? GPUs have always been, different. They have unique challenges that made people think they might be less vulnerable to this specific attack. Things like proprietary ways they map physical memory to the GDDR banks. It's not standardized like CPU memory often is. Plus high memory latency, faster refresh rates. These things usually make it harder to do the rapid hammering effectively. Right. And on top of that, the GDDR memory itself often has its own built-in proprietary mitigations. Trying to figure those out to reverse engineer them is tough. The researchers' paper really lays out these hurdles.
But they did manage it. They showed it working.
They did, yeah. Successfully demonstrated it using an NVIDIA A6000 GPU that uses GDDR6 memory. But here's the really critical detail, the kicker. The attack failed when ECC was turned on.
ECC. Error-correcting code memory.
Exactly. That's the memory type designed to detect and fix these kinds of single-bit errors automatically, often found in servers, workstations, more robust systems.
So if ECC stopped it, what's NVIDIA saying people should do?
Well, NVIDIA's recommendation lines up perfectly with that finding. They've released a mitigation advisory, and it is essentially implement system-level ECC across the affected NVIDIA products. So this really brings it home, It highlights how crucial these fundamental memory integrity measures are, even for really advanced hardware like modern GPUs. Old threats finding new surfaces.
Fascinating. It's a good reminder that nothing's ever truly solved in security. Okay, so while rowhammer shows old threats coming back, our next topic is about how fast a new threat can blow up. Let's switch gears to Citrix Bleed 2. We've been watching this one, and things escalated quickly.
Right. Just as a quick reminder for everyone, the original Citrix Bleed, that was back in 2023, it was a way to bypass multi-factor authentication, MFA, on NetScaler gateway and ADC products. Usually involved a buffer overflow.
Okay, and this new one, Citrix Bleed 2, made public just last month, June 2025. Same products.
Same products, yes. But the mechanism is different this time. It uses something called an out-of-bounds memory read to get past authentication.
An out-of-bounds read. What does that actually let an attacker do?
So think of it like the system is told to read data from a specific spot in its memory, like reading page 10 of a book. But the exploit tricks it into reading past the end of that allowed space, maybe reading data from page 11 or 12, which it shouldn't have access to. That unintended data it reads could be anything sensitive. Session tokens, credentials, internal system information, basically stuff that lets the attacker bypass security checks or gain unauthorized access.
That sounds bad. Really bad. And we know this isn't just theoretical anymore. It's actually being used.
Absolutely. That's the big development. The official identifier for this vulnerability, CVE 2025-5777, was just added to the CISA Known Exploited Vulnerability Catalog, the KE list.
CISA's list. That means they have confirmed evidence it's being actively exploited in the wild.
Precisely. And it carries a high CVSS score, 9.3, reflecting just how severe it is.
Which is quite a change from what Citrix initially said, right? Didn't they originally say there was no active exploitation?
They did. That was the initial statement. But they've walked that back now.
Wait.
This really rapid shift from nothing to see here to it's being actively exploited happened incredibly fast. It came right after researchers published not one, but two working exploit versions. One had the, let's say, memorable name PC or GTFO,
Okay.
and almost simultaneously, data from gray noise honeypots started showing attempts to use this exploit going back as early as June 23rd.
Honeypots. So
Yeah.
catching attackers in the act.
Exactly. Those decoy systems confirmed people were already trying to use it.
Yeah.
It just shows the sheer speed vulnerabilities can be weaponized today. One day it's a paper, the next it's actively hitting systems.
So the bottom line, for anyone listening who uses these Citrix products or manages systems with them, what's the immediate action?
Patch immediately. That's paramount. But it's also, a stark reminder to stay incredibly informed and maybe validate vendor statements with independent threat intelligence when possible. Things move fast.
Definitely. Okay, so that wraps up our deep dive for today. We've seen how an older threat, Rowhammer, got a new lease on life-attacking GPUs, and we watched Citrix Bleed 2 go from zero to critical emergency almost instantly.
Yeah, if you connect the dots, both stories really paint a picture of just how dynamic cybersecurity is now. On one side, you have these fundamental, almost foundational memory attacks finding new ways to work against modern hardware. It tells us you can never assume a vulnerability is truly dead. And on the other side, you see critical remote access vulnerabilities going from disclosure to widespread exploitation in, well, days sometimes. The response time required keeps shrinking.
It really makes you wonder, doesn't it? How quickly can we as users, as organizations, really adapt? How fast do our defenses need to be? Definitely something to chew on this week. We hope you found these insights useful, maybe a little intriguing. Until next time, keep exploring, keep questioning, and thanks for joining us on this deep dive.